Well, thank you. And it is a pleasure and honor for me to be here. I have been involved in this topic for the past 2 decades. It is a very controversial topic. I was very impressed with the questions that Karamay forwarded to me that you had put forth. And we're going to talk about some of those a little bit. And my preference in giving a presentation is for it to be very informal. And if it's okay with these 2 people here, if there are questions as we go along, please feel free to interrupt me and we'll have a discussion. I actually prefer that type of format. I have not been to Yale before, but one thing that I see is that students don't sit at the front, just like they don't sit at the front at NC State, where I teach. So I'm used to that. I'm going to talk about several topics this afternoon, primarily related to the issues surrounding animal production agriculture. I know that the topic in your module is beef. I have very little experience with beef, but I will tell you that the issues related to the environmental component are almost the same. And I'm going to talk about that a little bit. I have a lot of colleagues at other institutions that have spent their career on waste management issues related to beef production, especially colleagues at Texas A&M and parts of the Midwest. But again, the societal and the environmental, the sustainability issues are the same. And I hope that I can make that point with you this afternoon. One thing that I want to start with is making a distinction between animal feeding operations and concentrated animal feeding operations. You see this misrepresented repeatedly in actually the peer-reviewed scientific literature. And I kind of hate to admit it, but I am a co-author on a paper now with some people at Duke University where we have looked at the impact of estrogens from livestock operations on the environment, fate and transport. And the facility that we used is clearly an animal feeding operation. It is not a concentrated animal feeding operation. But my colleagues on that paper are insisting that we continue to keep the term CAFO in the paper because that is what everyone identifies with. But I want you to be aware of the distinction, and this is an EPA rule. Animal feeding operations are operations where the animals are kept and raised in confined situations. Feed is brought into the animals rather than the animals grazing or consuming feed that is grown in that area. And jumping ahead a little bit, and this is an area, and I told Karamay when she contacted me about this several months ago, that I'm someone that gets yelled at by both sides. I get yelled at a lot by the environmentalists. I get yelled at a lot by the industry. And I think you'll see why that's apparent as we go through the presentation. And as long as I'm being yelled at by both sides, I'm okay with that. But from a sustainable issue, which one component of what you're talking about in this course, a lot of the animal feeding operations and concentrated animal feeding operations bring the feed in from outside. And the meat product goes to the consumer often outside of that area, most often outside of that area. In North Carolina, the East Coast corridor the Northeast corridor is a big customer-based area for the meat that is produced in North Carolina. But with the feed coming into North Carolina and the waste products staying close to where the animals are produced, that is not a sustainable situation. So just jumping ahead a little bit, feed is brought in, and by definition, an animal feeding operation is under that environmental condition for a total of 45 days or more in any 12-month period. It is not the calendar year. It is a consecutive 12-month period, and crops, vegetation, forage growth, or post-harvest residues are not maintained in that area. That is an animal feeding operation. Now, EPA identifies a concentrated animal feeding operation as one in which essentially has these numbers for these animal sectors. And for your group, you're interested in cattle. So anything that would be 1,000 head or more would be a concentrated animal feeding operation, if it is indeed, and trust me, it will be a CAFO, but it first has to be, rather an AFO. It first has to be an AFO before it can be a CAFO. Now, what you will see, and this is the case.
Just quick, is 1,000 per a unit, like a hectare, or is it just
whatever it is within that permitted unit.
Okay.
So it would be within a unit that would have the permit.
Okay, thank you.
So what you will often see, and where we were doing the estrogen study, it was on a swine operation, and this is not uncommon. You will see a lot of these animal units that will have just below this threshold. This is where it will be designed for, and this will be the number that was maintained. On ours with the swine operation, I think the facility that we did the study, they were permitted for 2,400 animals. And I think you can understand the logic of that. They don't want to be characterized into that CAFO because more so in the past than now, although this can always change, the regulations, if you are a CAFO, are significantly different or can be significantly different as compared to an AFO. Now, at one time, EPA intended for all of these operations that would be in this category to be required to have an NPDES permit. That has gone through the court system repeatedly over the past decade. EPA has been sued by both the industry as well as the environmental groups on that topic. Currently, there is no requirement to have an NPDES permit even if you have this number of animals or more, unless you are found to be discharging to surface waters of that state. And that is a violation of the Clean Water Act. And they have been back and forth about this, but that's where it currently stands now. You do not have to have NPDES unless you discharge. If you're found to be discharging, yes, they're going to put you under the requirement of having that permit. And that's where the medium and small CAFOs come into characterization. These units do not require, even under the earlier laws where EPA wanted everyone to have an NPDES that would be in this category, these are not required to have that, but they would be if they were found to be in violation relative to discharge of animal waste residues to surface waters. So, if you are a small CAFO and you get a call from EPA that you are required to do an NPDES because you have been found to be in violation, that is a very, very bad day for you. So, we could talk. I teach 3 lectures on these regulations in a course that I teach every fall, and it's very complex, but I want you to be aware of these differences and the basis of why. So, before I go to that, did they have the slides in advance? No. Okay. So, when I'm on an airplane and the person next to you says, okay, what do you do? And I tell them the type work I do, and then I start. They say, well, what does that involve? And I start talking about some of these numbers. Most of the people in society are just absolutely flabbergasted by these numbers. So, if I ask you on a day-to-day basis in the U.S., how many head of cattle, your unit is cattle, are on the ground in the U.S., approximately?
Is it ballpark about 100 million?
Anyone else? He got it almost exactly right. It's about 100 million. What about swine? Anyone want to put forth a guess? Day-to-day inventory, swine.
10 million.
We have 10 million. We have 50. You got the first one right. What do you think with swine?
I'd say more like 100.
You're right again. You're right again. So, 100, approximately 100. Day-to-day inventory. Let's talk about poultry a little bit. Meat-type chickens. How many?
100 million.
100 million. We have, and this would be. I want to go back a little bit. For the meat-type chickens, let's do the number that are produced annually in the U.S. that are put into the cellophane in the market and go to the KFCs and those type places. How many per year in the U.S. only?
800 million.
Yeah.
800. Got a billion. Anyone else? I've heard a billion as the highest. It's about 8.5 billion. Table eggs. Table eggs that we have. I had a couple boiled eggs for breakfast this morning. How many table eggs per year? How many? 80 billion. So, 80 billion.
In the U.S. only.
And this is only in the U.S. This is only in the U.S.
This is probably consumed in the U.S. then.
Yeah, and I want to make clear, the young man was correct on the day-to-day inventory on cattle, but these are actual production. This would be approximately slaughter number, and I actually think this number is a little bit low. But I got this from the American Meat Institute, and they're usually pretty spot on with their numbers. They're pretty objective. You see, a little over 100 million hogs, 8.5 billion head of chickens, 80 billion eggs. If you consider the economics, and you have, yes, question.
The beef doesn't include dairy cattle.
That's correct.
Meat.
That is correct. Good point. And I also didn't put turkeys in this slide as well. We grow a lot of turkeys in North Carolina. But if you look at all livestock and poultry, in the dairy and the turkeys and the ones that I don't have here, that industry employs about 6 million people in the U.S. and is responsible for about $900 billion annually to the U.S. economy. That's a high percent of the gross national product. Now, but I want you to make sure that you understand this is all of the allied industries. This is from the farm gate and the allied industries that get the products into the consumer market. So it's a big industry. Question, back to the early. If you just look at this block here, is this an animal feeding operation? If you just look at that, the visual there, is that an animal feeding operation?
Way too spacious.
Well, the cover crop is being pretty well maintained. So this actually would not be, if you just look at this photo, that would not be an AFO.
But couldn't they conceivably be then moved into?
Oh yeah, absolutely, absolutely. And they probably are, especially the ones in this photo. How about this? Absolutely. So, the state that I'm from, yes sir?
Sorry, I have a question on the food stuff. Maybe we can go over this later, but do you have a breakdown of how that 900 billion plays out in each of the sectors within the supply chain?
I don't have that in the presentation today, but I have seen that data. That data is available.
I imagine it's much more heavily skewed toward the retail side than.
Oh, there's no question about that. Oh, okay, now I better understand your question. And I will go into this a little bit later because I know the multiplier. Because I'm not an economist, but I work with a lot of economists. So in North Carolina, the state that I'm from, North Carolina is often referred to as the #1 meat producing state in the nation. And I'm not sure if that's true or not, but we certainly produce a lot of livestock and poultry in North Carolina. About 800 million chickens, 35 million turkeys, 3.1 billion table eggs, and 18 million hogs per year. The day-to-day inventory of hogs in North Carolina is about 10 million. That's more, we don't have that many people in North Carolina.
What about other kind of eggs besides table eggs?
It would, for the industry, it would be for the breeder flocks. And those numbers are tremendous as well. Good question.
Before you go on, could you just, so what is the length of time that a beef, a swine, and a eating chicken are needed to grow? Because you said that at any one time there's some million, I forget what you said, there's 10 million hogs, but there's 18 million slaughtered a year, so that would suggest that a hog takes less than a year to
Correct.
mature. Okay.
If you look at the day-to-day inventory, it's just less than double for that. And for chickens, it's every 6 to 7 weeks. So,
And that's where the breeder eggs then come in.
right, because you've got to maintain those flocks. So this is where we look at the economic aspect a little more specifically for a specific case. In North Carolina, and this will answer the prior question to some degree, the farm gate income for all agricultural commodities, livestock, poultry, crop, greenhouse, including tobacco. At one time, tobacco was a big industry in North Carolina. It is not such a big industry now. But livestock and poultry represent approximately 65% of the total agricultural economy in the state. So 65% of this total value of farm gate value is going to be from animal production agriculture. Now, the economists tell me, and this would be the revenue that would go to the producers. The economists tell me that you can conservatively multiply farm gate by a factor of 4 to 5 to get the total economic impact of getting the product to the consumer. Now, an interesting situation, and this relates to sustainability, it relates to, I think, the topic of your course. If you look at what has occurred in North Carolina, in 1991, the day-to-day inventory was about 3 million pigs on the ground. And then that rapidly grew over a period of just 5 to 6 years to a day-to-day inventory of approximately 10 million. And it has plateaued since then because of policy that was implemented in the state of North Carolina, which put a moratorium on expanding that industry. And the moratorium was based on environmental concerns, and exceptions to the moratorium require that remediation technologies be implemented that address specific environmental parameters. And we will be talking specifically about that because I've spent a lot of time in the past 2 decades on that specific topic. And again, the technologies overlap to poultry, beef, dairy, they overlap. And we'll talk about that. Had a question here?
Oh, yes, does the moratorium have an expiration date?
It does not. It does not. That's an interesting question because the political makeup of our legislature in North Carolina has changed significantly in the last 2 years. And you told me you're from Winston-Salem, right? So you probably know a little bit about this. And there have been some discussions in some stakeholder groups that the law that was implemented here could possibly be repealed. So that would be an expiration. But it doesn't have, the only restrictions, the only criteria associated with the moratorium now is that you have to have a technology that meets the criteria that are defined, which we will talk about. And if I'd had a little more time, I would have seen if I could have found you the numbers for beef on this. But I want to put this graphic up because of the work that we have done in North Carolina related to the technology development. There has been a lot of interest directed towards our initiative from all over the globe. And if you look at the U.S. compared to pork or poultry to other parts of the world, China in particular, you can understand that there is a lot of growth and there is a lot of desire to grow. And a lot of parts of the world have the same, or they should have the same environmental issues that we have here. And we have repeatedly been had collaborations with people in China, Asia, Australia, Europe to some degree. But that's the dynamics in Europe is a little bit different related to animal production, agriculture, and policy than these other parts of the world. So I wanted to point that out because there's interest in what we're doing relative to technology implementation in other parts of the world. In China, for example, they currently are producing half the pigs that are grown in the world, and they want to increase that number dramatically. And they are having environmental issues. And one point that I want to make with you is that, and this is one of the areas that I have gotten yelled at by some of the stakeholders, you really need to think about sustainability in multiple generations. I think you need to think about it as a minimum 5 generations from now. Not next year or next decade or next generation, but multiple generations in advance. And you have to consider it from a global perspective. I tell my students that and I'm from a conservative state, and this is another area that I have been yelled at a bit, but on the global warming issue, it's not a question of whether it's real, it's a question of whether we're going to do something about it or we're going to learn to live with the consequences. And if your policy is to move animal production agriculture from one part of the world to another just because of differing environmental regulations that make it easier to grow the animals there, that is not a good idea.
How much of, say, the pork production in China is foreign owned? Is any of it owned by, say, American companies?
That's true now. I don't know the percent of that, but there are American companies that have a significant presence in China.
And is any of that for export back to the United States?
Not to my knowledge. Okay. And this is where we start to talk about the environmental sustainability issues. And this would be true for poultry, beef, dairy. The example here is swine. If you look at what has happened in North Carolina, I showed you these numbers earlier. In 1991, we had, about 2.5 to 3 million pigs on the ground, and now it's 10 million. In 1970, the actual number of farms was 20,000. And now the actual number of farms on the ground in North Carolina are 2,000. And you see this trend worldwide for all of the livestock and poultry production commodities. Larger operations, fewer farms, more concentrated production. It is happening worldwide. We can discuss and we can debate whether that is good or not. If your objective is to grow the product as cost efficient as possible and also as nutritionally productive as possible, and also as pathogen reduced as possible. The concentrated animal production model, if you look at this objectively, often is the much better model as compared to the smaller facilities. And I'm teaching a course this semester, an honors course, and the topic is surrounding the controversial use of subtherapeutic antibiotics in animal production agriculture. And one of my invited speakers, who was not a veterinarian for a company, but he was an academic veterinarian, he made the comment that he will not purchase pork that is from certain chains because they are only getting local grown, free range animals. And he said we are now starting to see trichinosis in those populations again. And so it is an issue. It is a consideration that you need to think about. And I understand that it is very, very controversial. Now, this is the slide that I want to make some comparisons related to your topic. I've incorporated several visuals of cattle and dairy feedlots here. Visual 1, 2, 4, and 5 are all with that commodity. And this visual is one of the farms that we use as a control site with our technology performance verification work. And this is a compost facility that is a technology application. And I want to make the distinction there that you have two considerations with all of these commodities. It's a liquid waste stream and a solid waste stream. And the way that you treat them from a technology perspective would be different in most cases. Well, the dairy and cattle operations, this is a holding retention, runoff retention facility associated with a cattle feedlot. So when you see these and these and these, you are going to have these associated with it. And you're going to also, in most environments, be collecting the solids from the waste, from the dairy operations and the cattle operations that could then be further processed in a composting or other type of treatment for solids application. I'm not a big fan of composting. It's okay. There are some benefits. You will kill the pathogens. As you're going to hear me talk about a little bit later, I've got a real issue with ammonia emissions. And composting operations, you're definitely going to be losing ammonia from composting operations. But in these types of environments, with the animals and the waste that is being produced, and the way that the waste is being held, the slurry being held in these open environments, whether it is this type of retention pond with a cattle operation or a so-called lagoon with a swine operation. This is a swine operation in North Carolina. From the actual surfaces, and especially if you get some wind current across the surface of this lagoon or this holding area, and especially from within the buildings, you are losing tremendous amounts of ammonia. We are losing metric tons of ammonia from these livestock and poultry operations. And I'm going to tell you a little bit later why I think that is such a big issue. I think it is one of the main contributing issues to why these types of systems are not generationally sustainable. It's the ammonia emissions. That is the big issue. So let's talk about some of the specific environmental parameters that are not just North Carolina, but nationally, that are either being regulated or are emerging issues or are being impacted by policy. First are nutrients. And what I have done here is put in red some of the parameters that are, in my view, emerging issues of importance. You're starting to hear a lot more about it, even with the political climate that we have now in Washington and in some of the states. Surprisingly, there's only one parameter on this slide that represents the majority of regulatory requirement for livestock and poultry production in the U.S. and to a large degree the world. It's only one of them. What do you think it is? No. EPA doesn't even regulate odor. It's probably the most controversial one. But from a if I am a producer that is producing these millions and billions of animals, I have to go out and get, and I'm an AFO, and I have to go out and get from my state or from EPA a permit. Which one of these do you think drives that train?
Is it nutrients?
It's nutrients. And which one of those nutrients do you think it is?
Probably nitrogen.
It's nitrogen. It's nitrogen. Most of the permit requirements are going to be based on land application of nitrogen from the animal waste that would be based on the ability of the receiving crop to assimilate that nitrogen. So, it could be an advantage to a producer to be volatilizing a lot of ammonia before it gets to the crop area, the field that you're going to apply for crop, if you are land limited. That's an issue. In some cases, it will be nitrogen and phosphorus. But because of the phosphorus content, and because the majority of the regulations are based on nitrogen, and this would be true for cattle, you will be accumulating phosphorus in high concentrations in that land area where you are applying that waste. And this is the second reason that I think the current systems are not generationally sustainable. Because at one time we did not think that phosphorus transported readily, but phosphorus under certain soil type conditions and under certain concentrations can transport very readily. Not as readily as nitrogen, but it will transport. And it will transport laterally, it will get into surface waters, and it will cause eutrophication. Most streams relative to eutrophication are going to be more sensitive to phosphorus than they are nitrogen. So that's That's an issue. Metals, copper and zinc, when you add higher than the nutritional requirement of these two metals to livestock and poultry, you will increase feed conversion rate. And especially with the current grain prices, that is an economically favorable equation because these are inexpensive nutrients. But they're going to accumulate, they're going to be excreted by the animal, and they're going to be land applied along with the nitrogen, and like phosphorus, even more so than phosphorus, they're not going to transport out of that land area. And in certain concentrations, if it builds up to certain concentrations with certain soil types and certain receiving crops, it can become toxic to the crop. And once you have heavy metal toxicity, that is very, very difficult to remediate. It takes a long, long time. Arsenic I have in the red because that's an emerging issue. That's actually an issue that's kind of been addressed. Arsenic is a component of some of the antimicrobial pharmaceuticals that have been used in the poultry industry. These pharmaceuticals are a very, very effective coccidiostat. However, because of the buildup of the arsenic, the company that was producing this pharmaceutical was purchased by Pfizer, and Pfizer, in my view, did not want the public bad publicity that would come with that, so they have mandated it to be taken off the market. So you can no longer use that compound in the poultry industry. Pathogenic bacteria. Big topic, emerging topic is antibiotic resistance, because with a lot of these industries, there are considerable amounts of subtherapeutic antibiotics being used, being added to the feed, because again, and the literature is very clear on this, from a nutritional perspective, you will get a very significant improved feed conversion rate by adding subtherapeutic antibiotics to the feed or the water. And then the question becomes, what impact is that having on antibiotic resistance? Development of antibiotic resistant bacteria that may then get into the population and impact human health. And I have participated in some epidemiology studies, and I can tell you this, if you go sample these animal feeding operations, those facilities like I showed you in the earlier slide with the cattle and the poultry and the swine, you will find antibiotic resistant bacteria there. And you will find the antibiotics there as well. They will be there in the actual waste excreta in part per million concentrations. If you sample the surface waters around those areas or the shallow aquifer, you will find them in part per trillion concentrations. So then the question becomes, how much of a risk is that? Because one of the speakers that I had to this class that I'm teaching this semester, they showed a very detailed life cycle analysis that showed the impact of adding the very low concentrations of antibiotic to the feed relative to the reduced amount of corn crop you would need to raise, soybean crop you would need to raise, diesel fuel needed for transport. It was very, very significant. So then you have to look at what are the risks versus the benefits, because the risks are not zero. I think if you look at it objectively, and the epidemiology studies that I have been involved with scientists from UNC School of Public Health, Duke University, Wake Forest Med School, we just didn't see the phenotype of the antibiotic resistant that was on the farm getting into the gut of the workers or the people living on the farms. But the risk is not zero. The risk is not zero. Ammonia emissions. Let me talk about ammonia emissions. I've made the case that we're losing a lot of ammonia from these operations. Why is it significant relative to sustainability? We did, as part of our study with looking at these various technologies, a cost-benefit analysis, because the question always comes up, or should come up, about the externality cost associated with livestock production. Again, this is true with cattle. This is especially true with cattle. There's a lot of ammonia lost from these cattle feedlots. And the surprising thing that I learned in the cost-benefit analysis was that when we monetized the cost to society of nutrients, metals, pathogenic bacteria, odor, and ammonia, ammonia trumped the other four by 80-fold. And the reason for that is because ammonia in the atmosphere, as I'm sure several of you know, will react with acidic compounds and be converted to fine particle particulates. And if it's converted to fine particle particulate, then when we respire it, there are health consequences. And the objective determination of the cost of that is very significant. So that's why, and one of you actually asked this question, it was a great question, asked that very question. If you're looking at these different criteria, which one is the most important relative to which technology do you choose? So I always feel you have to put top priority for that reason on reducing ammonia emissions. There's also the rules and regulations at the state and the federal level, but then there's public perception. And I can tell you that public perception is really driving practices in livestock and poultry production now. I had a meeting, I spent a lot of time with the corporate people in these industries. I spend a lot of time with the environmental groups and the community groups. But I was in a meeting a couple of months ago where one of the corporate managers of a major animal food production industry made the comment to me that he said, you know, we're not so much worried about EPA anymore. The new EPA is Walmart and McDonald's and Chipotle. And I found this one because I knew that you had a Chipotle exercise with one of your classes. And again, is that good or bad? I can tell you that it is having an impact. It's having an impact on the way these animals are produced. And it is having an impact much more significant than anything that I have seen from a public policy, regulatory, and rulemaking process in the last 2 decades. So again, in North Carolina, when the moratorium was implemented, this is what the legislature put in place. They said if you want to expand, you must eliminate the discharge of nutrients, nitrogen, phosphorus to surface and groundwater. For the other 4, the North Carolina legislature said you must significantly reduce each of these. So what does significantly reduce mean? And I think this is an example of how public policy plays out in an interesting way. Because then when we went to the technology process development, the Attorney General's office said, well, the North Carolina legislature has already enacted what the environmental parameters are. That's not a negotiable item. So in the process of looking at these technologies, we had to quantify what significantly reduce means. And then once we did that, it got incorporated in a subsequent legislative session and went through the Environmental Management Commission and was codified into law. So now we know exactly how many kilograms of ammonia we have to reduce. We know exactly what the odor reductions have to be. We know exactly how many log reductions we have to get with pathogens. So I used to be really annoyed when I was involved with this process, the technology development process, of what we had inherited from the legislative body. But then after I went through it, I said, you know, it really is the way that it should work, because the elected officials should not have been the ones quantifying those parameters. It needed to be people that were made up of public health officials, scientists, engineers, and that's what we did. So I think that was a good example. One of you asked the question, what was the driving, and this was a great question, what was the driving force behind that company, Smithfield Foods, putting up $15 million to do these technology developments and performance verifications? Well, the Attorney General negotiated that amount with the company, and I think it's safe to say that if the company had not agreed to do that, there probably at that time would have been a class action lawsuit of some type that would have been put in place. So, for the technology getting to the science, which takes a lot of resources, scientific research is expensive. We were provided a good chunk of resources to develop technology and then objectively determine how the technology impacted these environmental parameters. And also we were mandated to determine what the cost would be. And it took us about 5 years to do that, but we looked at about 15 technologies that we took from start to finish. And we developed, quantified the performance standards. And in these technologies, there's a variety of applications, from simple to complex. Anaerobic digestion. Anaerobic digestion that is done at ambient temperature, mesophilic temperature, thermophilic temperature, low solid concentration, high solid concentration, nitrification, denitrification type systems, solid separation systems, even constructed wetlands, which actually work pretty well, but you still are losing appreciable ammonia from constructed wetlands. One of you indicated that this recip wetland would be a good system to look at because of its simplicity, and that's true. We found of these systems 5 that actually met the environmental criteria, and we found about 4 that were on the bubble, because the way this was set up, it had to meet all 5 of the environmental criteria. If it hit a home run on 4 and just did miss the 5th, couldn't count. It could not be used to meet the moratorium exception. But that reciprocating wetland system was low cost, and I think with a little value engineering probably could be made to meet all 5 of those criteria. So let's look at the systems that were shown to meet the environmental standards. And this, again, would apply for cattle, co-products, or waste products. And I used in this visual such that if you go and look at this report, it's easy to find what the companies that were sponsoring the work for the individual technology developments. And this was a peer-reviewed process. We solicited proposals from academic institutions, industry groups, technology suppliers, and I appointed a scientific review panel, and we got about 100 or so proposals, and from those we chose 18, 15 of them were taken to completion. And this was the company name, Super Soils. It's been changed now to Terra Blue. But this is a system in which the liquid slurry, so you could take the slurry coming off of those cattle facilities and process it in this system, and I'm sure you would get equal results. It goes through a polymer solid separation process to drop out the solids, to drop out the metals, to drop out the phosphorus. Organic ammonia will stay in solution, and then, like a small municipality system, that ammonia is nitrified. That's one reason it's expensive. You have to provide energy to do the aeration to get the nitrification. Then it goes through an anaerobic environment. You got plenty of carbon from the animal waste, so you get good denitrification. So you're addressing ammonia emissions. You're converting it to nitrogen gas, and there's an argument, well, is that the best thing to do? Shouldn't we be converting it to something that could be more readily recycled as a fertilizer instead of putting it back into the atmosphere as nitrogen gas? This is a fluidized bed combustion. Each of these four are technologies that only treat the solid component. The fluidized bed combustion process is very similar to the gasification of solids process. You can get an energy component as part of the process, the same way that you get with anaerobic digestion to convert it to methane, to convert the carbon to methane. This is a high solid anaerobic digester. Most anaerobic digesters that you read about are going to be digesters that treat a high liquid concentration in the 3 to 6, maybe as high as 12% solids range. This one would almost treat solids in the same concentration as you would have in a composting unit. And the end product is methane, which can then be combusted and converted into electricity with the generator. But that brings us back to another policy issue. And this is an area that I've been very disappointed. When we were doing this project, 2000 to 2005, I was confident that by now we would have a good carbon credit policy in the U.S. and that we would have good return for green energy that was going back into the grid. And it just has not happened. In North Carolina, we at least did get a renewable energy portfolio standard finally passed in about 2007. And it did have an earmark that a certain component of the green energy had to come from livestock. But it was very, very low. And it's also structured such that the power purchase agreements that the producers have to enter into with the utilities are very restrictive. And trust me, I have been yelled at a lot by stating that position. A lot. But it's true. And I invite anyone to look at it objectively. And I invite anyone to look at what has happened and what's on the ground. There are very, very few of these on the ground in North Carolina. And this is true nationwide. And I get it that this is a more expensive way to generate electricity. And the utilities do not want to bear that cost and that be and impact their shareholders. But I also feel that if we look at the impact of the economy to this industry, if you want to sustain the industry, why would you not provide some incentives that would be beneficial to not only the producers but all of the other people associated with that segment of the economy? And it certainly would be good for the environment. But I've been very, very disappointed in both the carbon credit policy and the green energy policy directions. I think we've got a long ways to go in this country on that. Getting more into the technical component a little bit. I'm going to show you cost, and a lot of you with your questions and comments picked up on this. This technology, and this is the super soil technology that is now they've changed their name to Terra Blue. We are now in a third generation of that technology because it's expensive, and our engineers have taken an approach with the company, and we've actually got some state support to do this, to try to apply value engineering and get that cost down. And we've had some success. It's still not where we'd like for it to be, but we have brought the cost down. But look at this. If you think back to that slide 7 or 9 that I showed you, the lagoons and the cattle lots, this looks very different associated with the animal production units. And it is very effective in addressing the environmental parameters that we have targeted. This was the generation 2 that we worked with, and I want to show you this one because it gives you a little better perspective of the actual technology. And this would be one of about 15 livestock buildings that are on that property. And this is a relatively small footprint to treat that waste stream. Because let's play the numbers game again. If we go back to, let's choose your commodity topic, cattle. Per 1,000 pound live weight on a daily basis, and this does not include any flush work, on a daily basis, fecal material and urine, how many pounds are going to be excreted per 1,000 pound live weight? Who wants to make a guess? Daily basis. You saw the numbers, you saw the inventory. We got about 100 million on the ground. Per 1,000 pounds on a daily basis, how many pounds of fecal material and urine combined would be generated per cattle, 1,000 pounds? We've got 20 pounds. You've been on a roll. I got to have a number from you.
Oh man, but it's nice to stop ahead.
How much do they eat? What's the poundage of consumption?
And drink. Intake.
You know, I'm not sure I can answer that question definitively for cattle. I can tell you this, the nutrients that are consumed by cattle, the feed conversion is about the worst. It is the worst of the other commodities that we've talked about. Of the nutrients, 70 to 90% are going to be excreted. It's much less in poultry, a lot less in fish. I saw that you had aquaculture as one of your topics. Okay, we've got 20 pounds and 100 pounds. Should have stopped while you were ahead. For cattle, it's going to be for beef cattle, it's going to be probably about 50 pounds. For dairy, it's going to be probably closer to 80 to 90 pounds, much higher for dairy. So for swine, per 1,000 pound, yes,
Why is that? Why is it higher for dairy cattle?
the diet, the dietary component. Your objective with the dairy is to generate milk, not meat. So swine per 1,000 pound, live weight, fecal material and urine, no flush water, per day. Anybody want to guess?
Less.
It's interestingly about the same as dairy. It's about 90 pounds per day. So, getting back to the point, at this particular facility, 5,600 head, average live weight per head is going to be about 150 pounds on a year-round basis, steady-state live weight. So you can do the math and calculate how many kilograms per day is going to have to go through the system. So that's a small footprint. It's a pretty small footprint. And I have no research dollars or no vested interest with super soils of Terra Blue. Just an overview of the results, and I put the reference in here. All of this work that we did, it's published. It's public domain. And you can see there, it literally is thousands of pages with these various reports. And you can see the various materials and methods and the science behind how we derive these numbers. But look at these reductions on carbon, solid, ammonia, phosphorus, pathogens, 4-log reduction, odor compounds, almost 100% reduction, heavy metals, almost 100%. Change gears a little bit, just such that I don't come across as promoting the super soils of Terra Blue system. And this system would also work for cattle. It would work for any type of system that you would have a liquid slurry waste coming off of, and you definitely have that with cattle. This is a system that uses an anaerobic digester that is earthen, low cost. It's not tank, as you saw with some of the previous visuals. It's covered to make it an anaerobic system. And then once the waste is treated, it comes out of the anaerobic digestion unit into this baffled area of this holding pond. And then it is processed through these trickling filters, which are these. And one of the reasons the super soil was so expensive was because of the energy used to nitrify the ammonia once it goes in the system. And one thing you will do with anaerobic digestion systems is you will conserve ammonia. You're not going to be volatilizing it, which is good. But you're going to have it at some point that you must treat it, or it will volatilize. So the researchers here said, okay, let's use just a low energy trickling filter with high surface area on beads within the tanks of the nitrifying bacteria and see if we can get good nitrification. They did. It worked quite well. It just couldn't get it quite to the threshold that we needed to meet the criteria. This system met the odor, pathogen, metals, nutrient. It met 4 of the 5, so it didn't qualify. And this is another area, another value engineering area that we're looking at from an R&D perspective. We have continued to try to make these trickling filters more efficient, and I think we're almost there.
Mike, I'm going to do a quick time check. Class ends in about 11 minutes. I want to give people time to ask a few
Okay.
questions, so whatever you...
We'll zip through. We'll zip through the last 2 or 3. But also with this system, some of the nutrients, after it was nitrified, was used for vegetable production in these greenhouses. And I want to show you this because I saw that you also had a tomato component. And it worked quite well, worked very well. We worked with the School of Public Health at UNC, our big basketball rival, to look at the pathogens, and they found that there essentially were no pathogens transmitted to these tomatoes. Mark Sopsey, who led that study from UNC, he said, tomatoes that you purchase in the market get many more pathogens on it from the people that pick them up and put them back down than they were getting from this system. I put this slide in because I wanted you to see the beauty of the science. I mean, this is a tough issue, but the science is really exciting. It's really exciting. And in this system, we worked with Sue Schiffman at Duke University to do the odor modeling, and she used an Eulerian-Lagrangian model. And actually, on each of the farm systems that we looked at, if you were looking down from above, she modeled this such that you were looking at 10-meter squares. And at each point, and this was based on odor panel analysis and samples that were taken, she developed this model where Y would be the number of odor parcels that were released from a point on that 10-meter square. And then you could model the dispersion. And X would be the odor panel determination from 0 to 8. 0 is no odor, 8 is extremely offensive odor. So, and then we looked at it because we had to take into consideration property lines. So we looked at it east, west, north, and south. So in this model, if you look at this south orientation would be the south orientation of this overhead shot here. And this 1, 2, 3, 4, 5, 6 buildings would be the 1, 2, 3, 4, 5, 6 buildings. It's all red. Intense odor inside the building, as you would anticipate. But then, when the wind was coming from that direction, you can see how quickly it dispersed by distance. And that's pretty good. This one actually met the odor standards for the criteria. But isn't that neat science? So again, this technology was one, low cost. It did really well on everything except ammonia. And we're working on that component now. And again, I think we're almost there. Economic feasibility determination. The bullets in black were what we were mandated to do with the Attorney General agreement for all of these technologies. And that essentially is a cost returns analysis. The controversial component was what is in blue. I agreed that we would do a cost benefit analysis. That was, I had no idea how controversial that would be. But I stand by it. I think you have to do the externality cost to monetize the impact to society. And these are the numbers, but these are the cost returns numbers. We were prevented by the structure of the agreement for putting in the externality cost. So you can see with the baseline system is about $90. These economists drive me crazy getting these values down to the penny. But you can see this is generation 1. It was much more expensive. The generation 2, they knocked off about $100 on the unit cost. And I'm looking at some modified numbers with some assumptions that we think we're going to meet with the 3rd generation, and I think we're going to be getting close. Now, per the mandate, per the law, per the agreement, we don't have to get to that. But we do have to get it down to about 115. And that's a different discussion because we had to go through the economic feasibility determination, and at the end of the day, we made a determination that at this cost, you can put no more than these many people out of business or reduce the herd size by this value. And that value was determined to be 12% of the total herd size. Again, that was a tough process to work through, and believe me, not everyone agreed with that 12%. Some thought it should be 50, some thought it should be 0. So, what have I learned in dealing with this for 2 decades? And I'm not bragging about this, but I have been in some tough situations. I have had my life threatened dealing with this topic, real threats. At the end of the day, I think you have to look at the triple bottom line. Yes, these jobs and the economy do matter to these people. The cost to society do matter. You have to consider the externality cost. And of course, the environment matters. That's where I have gotten in trouble with the industry side. It's not sustainable. I don't think there's some problem areas, but I don't think there's real crisis areas right now. But if you look at it generationally, it is not sustainable, and it's going to be some serious consequences if we don't address it. So, with that, I'll take questions. And I think I've been told I have to turn this off now.